So this is my presentation for the reverse engineering unit on this Piggy flashlight. So to start off, I was given this flashlight that lights up when you squeeze it, when you squeeze this handle. And in order to improve upon this design, I needed to understand what appealed to customers about it and its drawbacks. So to start off, 85% of the people we interviewed said that its cuteness and the creativity of the lights coming out of the nostrils added value to its design. So it made them pay more. But unfortunately, this is really where I saw the benefits stop. And the biggest glaring problem was that on average, people said they'd pay $5 to $12 for it, which is less than what it actually costs, which is around $14. So my design needed to actually be valuable enough for people to buy, so I looked into I needed to identify where these problems were coming from. And to start off, it was unanimous across the 20 people we interviewed that it needs to be rechargeable. As it is right now, you cannot replace the batteries and you cannot recharge the batteries. The handle just directly lights up these without going to the batteries. Second off is 17 out of the 20 people said they would not use it regularly, and that was because it wasn't practical, and that was mainly because it was very loud. So in order to get a baseline on its loudness, I measured it at 1 foot away, and I found it got up to 95 decibels, which is pretty loud. Next is 12 out of the 20 people found it confusing. They didn't figure out what especially this lock switch did, as it's not labeled. And lastly, but also pretty importantly, 7 out of the 20 people thought that if they used it for long enough, it could hurt their wrist. So you realize when you hold it now, it puts your wrist at a weird angle. So I wanted to find a way to solve for that. And the second reason they said it could hurt them is because it takes some considerable force to squeeze this handle, and if you were to do that enough times, it could start to strain your forearm. So trying to find a way to solve these led me to the design specifications. So first, obviously it needed to be rechargeable and have this handle power the batteries rather than the lights. Second off, the mechanics needed to generate far less noise, and I wanted to aim for 50 decibels rather than the 95 decibels that it currently makes. To make it more understandable, I'd want to put labels above the switches, and to make it more ergonomic, I decided I wanted the light to be able to switch by 90 degrees. So you can hold it like this. You can also hold it like this because the light can go that way, which is far more ergonomic of a wrist position. I also wanted it to take, instead of 6.4 newtons to squeeze the handle, I wanted it to take 3 newtons. Which led me to functional modeling. So this was my before sketch of about how it worked, and I was fairly close, with the linear gear and a one-way mechanism to spin the magnet around. However, once I did take it apart, I created a 3D model so I could really thoroughly understand what parts of the mechanics made mechanical energy turn into light. And I found it also really fascinating to learn how it actually works. And I found where the noise was coming from, which is on the release stroke. The one-way gear spins around in this magnet, and its backsides hit the sides of these spikes. which then creates a clicking sound and makes it pretty noisy. Which then, after this, led me to then come up with my design. First and foremost, it's a Cyclops robot. It's customizable, as in its head shapes come in 3 forms. There's happy, squinty-eyed, angry, and just neutral. And then it comes in 2 colors of blue and red, which is bound to draw in more customers. Now, its creative design is a far upgrade from the design of this, as the light comes through the Cyclops eye, and it has expressions, and it's high quality and cartoony, and has a big head that makes it look quite cute. It's also about this tall. And you may have noticed it has a transparent window in its chest, which I got the idea to do that as I was functionally modeling this, because I found it really interesting to take it apart and learn how it worked. So with this transparent window, people can squeeze the handle and watch in real time the linear gear spin these other gears that spins the magnet, runs the generator that then goes up to the battery, which can really draw in interest in learning and foster learning. So next, it has rechargeable batteries, and the handle goes directly to powering the batteries rather than the lights. And the on-off switch is the thing that obviously turns on the lights or not. And to make it more practical and quieter, I decided with the one-way gear on the back sides of this part, I would put on a softer material so it would absorb the shock and not create that loud sound going back. So that would quiet it down. Second, it's understandable because it has titles over the switches, as well as you can understand how it works by seeing into it. It's also ergonomic. With its sitting function, it can sit in your hand, which also upgrades its cuteness. You can like tilt its head and sit it in your hand like it's pictured there, or you can hold it as a normal flashlight when you flip the head all the way up, or you can hold it in its standing position, which is the natural position for the wrist that I was talking about. Lastly, to make it take less newtons to squeeze the handle, I made this gear a little bit smaller in proportion to this gear, so that the gear shift was smaller, which means it takes less force to move this gear, which means it takes less force to pump the handle. Therefore, it will take less newtons to squeeze. And this is also my exploded diagram of how all the pieces would fit together in the head down here and the body up here. And thank you for your time.